Start. Shall we?
Yes, sir.
Is it visible to everyone?
Yes, sir.
And now we'll see the walls are used in processing industries, chemical industries, or oil and gas industries. Now, walls, see, the estimates reveal that a substantial portion, approximately 2% of the total capital expenditure of the chemical process industry. See here, 8% of the total capital expenditure, the chemical process industry. It is used for the procurement of walls. In terms of the number of units also, walls exceed any other. Hence, proper design of the wall are done in such a way to perform any of the different functions. So, functions the wall is used in process industries. The four function of walls: isolation, regulation, non-written, and special purpose. This classification is based on functions. The walls could also be classified based on the type of constructions. Wall manufacture offer endless varieties of constructions based on the operations. Walls can be broadly classified as operated walls and self-operated walls. Mainly, the check walls are self-operated and all other types of walls came under operated walls. So that kind of walls, see, the operated and self-operated walls. In isolations walls, again isolations wall classified into gate walls, ball walls, plug walls, piston walls, pinch walls, diaphragm walls, and butterfly walls. Later we'll see details in all walls. First we'll see the classification of walls. Now next, regulation type of walls: globe wall, needle wall, piston wall, pinch walls, diaphragm walls, butterfly walls. These walls undercome the regulation type of walls. Now, third is non-return wall. There is only one check wall and special purpose wall. So, in special purpose wall, multi-port wall, flush bottom wall, float bottom wall, foot wall, line blind wall, and last one is a knife gate wall. These are the function based uh, walls. First one is isolation wall, second one is a regulation wall, third one is non-return wall, and fourth is special purpose walls. Again, they are classified into different walls: isolation wall, regulation wall, non-return wall, and special purpose wall. Some walls are classified based on the end connections. End connection means the arrangement of the attachment of the walls to the equipment or to the piping. So that type of walls are called end connections. In end connection walls, screw ends, socket welds, flange end, butt ends, wafer type end, and buttress end. So that kind of wall we call the end connection. And this again walls are classified. Again, walls can also be classified based on the material of construction. In material of construction, see the CI, ductile irons, bronze, gunmetals, carbon steel, stainless steel, alloy carbon steels, polypropylenes, UHMW-PE, UHMW-HDPE, and special alloys. And third one is fluoropolymer or elastomer line metals. And last type of material construction wall is a glass wall. These walls are used in different environments. So therefore, we have to consider these walls in process industries. It is for the piping engineer to select the same in consultation with process engineer to suit the process fluid. The environment in which the walls are installed is also to be considered for the selection of material of construction. However, the most commonly available walls are CII, ductile irons, bronze, gunmetal, carbon steel, stainless steels, alloy carbon steels, polypropylenes, UHMWP, UHMWHDPE, special alloys, fluoropolymer, elastomer, line metals, and glass. So that kind of material constructions are available for walls. Now here in a glance you can see the different kind of materials are used in chemical industries, process industries, oil and gas industries, or fluorocarbon services. Here you can see the stainless steel. So it is a combination of iron and carbons, and you can see the alloys, base material plus other alloying elements, and then we'll see the alloy materials other than the steels. Means here you can see the nickel base alloy, copper base alloy. Again, you see the alloy, again alloy steels. It is a combination of iron plus carbon plus other alloying elements. And they are again classified up for low alloy steels and high alloy steels. In low alloy steels, carbon steels, low temperature carbon steel. And high alloy steels, there is a high temperature carbon steel. Again, we see the high alloy steel classification is stainless steel. That is martensite stainless steel, ferritic, austenitic, and duplex. Duplex is a combination of ferritic and austenitic stainless steel. And here plain carbon steel. So that is iron plus carbon. This is the base materials for the plain carbon steel. So here we use the low carbon steels, medium carbon steel, and high carbon steel. So this is kind of classification of materials are used in chemical industries, petrochemical industries, and oil and gas sectors, and hydrofluorocarbon facilities. Might be you are studied in metallurgy engineering, all different kind of combination of alloys and alloy steels and plain carbon steels and stainless steels. Do not go in detail to see the all materials and their compositions. So in piping engineering, we'll refer ASTM, that is American Source of Testing of Material, Through this handbook, we can refer their properties and required materials for manufacturing piping fitting components as well as different walls. Now, see the terms used for wall specifications. First term is a pressure temperature rating. In pressure temperature rating is the maximum allowable sustained non-shock pressure at the corresponding temperature mentioned in the ASME standards. These are listed in ANSI B 16.34 and ANSI B 16.5. In this standard, so we'll see the pressure temperature ratings, the maximum allowable sustained non-shock pressure, this corresponding temperature mentioned in particular standards. Now next is a class. Here in class we see the 150 hash, 300 hash, 400 hash, 600 hash, 900 hash, 1500 hash, 2500 hash and 4500 hash. The value is specified by the pressure rating of the body of the walls. These are referred or specified by the American standards as per ASME 31.3. So we can pick the class for different walls: 150, 300, 400, 600, 900, 1500, 2500, and 4500 hash. That kind of pressure class is used in wall specification. Now, next terminology is a trim. Trim is comprised of stem, seat surfaces, back seal bushing, and other small internal parts that normally contact the surface fluids. So, whenever we use the different kind of components in walls, so that we have to consider trim and stem, seat surface, back seat bushing, and other small internal parts. So that are normally contact at the surface fluids. So here we can use that kind of terminology. Next terminology is the weight. In weight, we'll see the all parts which comes in contact with the surface fluid are called weighted parts. These weighted parts, all parts of the walls which came in contact with the surface fluid are called the weighted parts. Now, third is a wire drawing. In wire drawing, to indicate the pressure or premature erosion of the wall sheet caused by excessive velocity between sheet and the sheet disk. That is the reason here can indicate the premature erosion of the wall sheet. An erosion pattern is left as if a wire had been drawn between the sheet surface. The excessive velocity can occur when the wall is not checked tightly. A wire, water, oil, gas, relatively cool liquids, we call the WOG, that is water, oil, gas. WOG disc is the best defensive against wire drawing. Why it is a best defensive against the WOG disc? Because its resilience makes it easier to close tightly. Discs of harder material are to be closed carefully to prevent wire drawing. In LPG services, for instance, consider in LPG services, liquefied petroleum gas services, the wire drawing effect causes a threat of anti-refrigeration. The ice formation on the wedge will obstruct movement, thereby increasing the leakage through seat. So, this is the reason here The wedge will obstruct the movement and thereby increasing the leak through the sheets. Now, next terminology is a straight through flow. That is a straight through flow. This refers to the wall in which the closing elements is retracted entirely so that there is no restriction of flow. So that kind of terms are used in walls. And next terminology for wall is quarter turn walls. In quarter turn walls, where the entire portion of wall is achieved by 90 degrees turn of the closing element is called as quarter turn walls. Now next is a pressure drop. In pressure drop, the loss of pressure through resistance across the wall, while flow and is expressed in terms of equivalent length in pipe diameters. So here we can express the length in terms of current length in pipe diameters. And next is upstream pressure. This is the pressure of the fluid that enters the wall. This is sometimes referred to as inlet or supply pressure. It's called as upstream pressure. Now next term is downstream pressure. In downstream pressure, the pressure of the fluid that is discharged from the wall, and this is sometimes referred to as outlet or pressure. And next is LDR. LDR is nothing but leak detection and repair. It's called as a LDR. In LDR, that significance the leak detection to ensure that the fugitive entries in the systems can refer the standards EPY, that is a leak detection and quantification LDR, that identifies unintended or fugitive emission from equivalent in an oil and gas, chemical or petrochemical installation. It drives maintenance activities to reduce emission to the atmosphere effectively. Now, next terminology is LER. So, its significance the lowest achievable emission rate. It is the minimum rate of fugitive emission which is achieved by deploying proper sealing arrangements. So, for this process, lowest achievable emission rate LER, it is called LER. It minimizes rate of fugitive emission which is achieved by deploying proper sealing arrangement. So this is all about the terms used for wall specification. Now next is a class leakage. What kind of class leakage there in walls? Now class 1 here, modification of any class 2, 3 and 4. Class 1 is the modification of any class, second, third, or fourth, wall where design intent is the same as the basic class, but by agreement between user and specific and suppliers. So that kind of class comes under the class 1. Now next is class 2. In class 2, 0.5% of rated wall capacity. And for class 3, here 0.1 of the rated wall capacity. Earlier class 2 is zero point 0.5 rated wall capacity and class 3 is 0.1 rated capacity. And class 4, in class 4 is 0.01 of rated capacity. See the difference? They based on their rated capacity. Now class 5. In class 5, 5 into 10 raised to 4 ml per minute water per inch of orifice diameter per PSI differential. So that kind of water per inch of orifice diameters. Now next class, that is class 6. This class 6, you can see their standard as per ASME 16.13.3. Now next, first isolation wall. In isolation wall, I have seen different walls. First one is a gate wall, globe wall, check walls. These are the isolation walls. Gate wall, ball walls, plug wall, piston walls, pinch walls, diaphragm walls, and butterfly walls. Now, first we'll see the gate wall. The gate wall will see the different parts. The gate walls. See hand wheels, yoke, stem, gland packing, we call the seal, bonnet, walls. We call the isolations wall used in process industry. Means we use gate walls, ball walls, plug walls, piston walls, diaphragm walls, butterfly walls, and pinch walls. So, of these, the butterfly, diaphragm, and piston wall can be used for regulating the flow, whereas similarly, the globe wall design could be modified to use for pressure shutoff purpose. The present trend in industry is to go for quarter ton walls. For this, due to duty due to which easy of operations. The type of walls in this category are the ball walls. Another is pinch walls and butterfly walls. Ball and plug walls are also can be used for flow control with say port the closing elects. Moreover, the design of quadrant walls are inherently better suited for emission control applications. The linear stem movement of the gate and globe wall tends to open the path of emission release, and in its dynamic mode, emission can be dragged along the stem. See the different parts. See here the walls, hand wheels, stuffing box, packing materials, bonnet, gasket, stem, flange, gate or disc, body or page. We'll discuss one by one all parts. In the gate walls, you can see the line diagrams. Here we mark all parts in gate wall, and as well as you see the 3D in the gate walls. Now first part is body. In body, the body is the part which gets attached to the vessels. See, the body get attached to the vessels or piping. The classification of the body could be done depending upon the end connections. As earlier seen the end connections. End connection here, screw ends, socket weld ends, flange ends, butt ends, wafer type ends, and buttress ends. So that of ends could be done depending upon the end connection as indicated earlier. The body could also be specified based on the material of the construction of the same. Here, you seen the construction materials, that is CI, ductile iron, bronze, gunmetals, carbon steel, stainless steel, alloy carbon steels, polypropylenes, UHMWPE, UHMWHDPE, special alloys, fluoro, polymer or elasto, lime metals or glass. That kind of constructions the same. This could be forged or fabricated. The wall thickness and end to end or face to face dimension of the body The body shall be as per the regulatory code to which it is designed. Here we have to consider the regulatory code for the wall thickness and end-to-end or face-to-face dimension of the body. The end flange shall be integrally forged with the body. It can also be attached by welding. If so specified, the end connection shall suit the rating specified, means class 150, class 300, 400, 600, 900, 1500, 500, and 4500 hash. The flange connection shall be ANSIB 16.5 or any of the flange standards. The butt welding end connection shall be to ANSI P16.25 or any other end preparation required. The socket weld or screw connection shall be ANSIB 16.11 or any other equivalent standards. The body can have auxiliary connection such as that is bypass connection or drains. These are the auxiliary connection. Now next component is a bonnet. In bonnet, the classified based on the attachment of the same to the body. The type of connection normally adopted are bolted, bellow sealed, screw on, welded, union, and pressure seals. The bonnet connection shall be flange, make male and female, tongue and groove, or ring type joints. In low pressure rating walls, it may be flat face. The bonnet gasket is selected to shoot body bonnet connection. It can be corrugated a flat solid metal, flat metal jacketed asbestos filled metal ring joint, spiral wound asbestos filled or flat ring compressed asbestos. In case of low pressure rating, Teflons or Teflon filled for corrosive applications. Teflon or Teflon filled for corrosive applications, and for low temperature ratings go for the solid metals, flat metal jacketed, asbestos filled, metal ring joints, spiral wound asbestos filled ratings. The bellow sealed bonnets can be bolted or welded on the body. These are selected for very critical services like nuclear, very high temperature, and lethal services. The screw on bonnet or union bonnet is used for very low priorities application and small size walls. When walls are used for cryogenic services, extended bonnet design is used to take care of large insulation thickness. When used for very high temperature, bonnet attached with fins are also used. Now next component is wedge. This is the part which facilitates the service by its movement up and down. The type of wedges are first one is solid plain wedge, next one is solid flexible wedge, and third one is split wedge. When solid disc is wedged into the rigid body seat and the wall undergoes temperature changes, the wedge gets jammed in the seat and hence the flexible wedge and split wedge design is developed to overcome this difficulty. What kind of difficulties? They are jam in the seat, and therefore flexible wedge and split wedge design is developed to overcome this difficulty. Normally, the solid plane wedge is referred as solid wedge and split wedge is referred as flexible wedge. Solid wedge referred as solid wedge and split wedge is referred as flexible wedge. The design slightly alters with the manufacturers. Through the basis remain the same. The flexible wedge design is followed by wall size 50 nominal bore, that is 50 NB and above. Walls 40 and below are available in solid wedge. Here, walls 40 nominal bore and below available in solid wedge design only. Flexible wedge design is supporting as it will not get jammed during high temperature operations. The wedge material should be at least of the same quality as that of the body. In case of integral sheet rings, the wedge circumference is deposited with the superior quality materials. In smaller walls, the whole wedge will be manufactured out of superior material. Any doubts up till now? Yes.
No, sir, no doubts.
Okay. Uh, Now next component is stem. Here you see the stem. Number 6 we call the stem. So or through this sketch you can see the stem here. Stem it connects the hand wheel. Say at the top there is a hand wheel and the wedge for operations. Stem connects the hand wheel and the wedge for operations. The design can have rising stem and non-rising stems. The stem is operated rotating the stem nut by hand wheel mounted at the top of the yoke. In the rising stem design, the stem moves up along the wedge to open. This is called OS and Y, means outside screw and yoke type of design. In case of non-rising stem, the wedge moves up and down and the stem is stationary. This is called the inside screw design. Normally, bar stock or forging are used for construction of stems. Now next component is a gland flange, packing and lanterns. So that kind of packing materials, glands and gland flange. The help of glands, packing gland and packings. So there are two types of gland design possibles. First is a single piece and two piece. In two piece of design, there will be gland flange and follower. The follower will have a spherical end which facilitates proper alignment of followers and loading on the packing. In single piece, the gland and follower will be integral. This design is used mostly in low pressure valves. Normally, gland follower will be of superior material than the gland flange. Gland flanges are made up of carbon steel only. The gland flanges are bolted to bonnet with gland eye bolts in low pressure valves. The regulatory code specifies that the stuffing box should accommodate minimum 6 packing rings for class 150 hash class. As regards higher rating valves, it should have lantern rings with 5 packing rings above and 2 packing rings below lantern. Lantern is not provided for class 150 hash. Lanterns is provided for higher ratings if required. When lantern is provided, the stuffing box shall be provided with 2 plug holes. The material of lantern shall have corrosion resistance equal to that of body. Normally, the packing is of braided asbestos suitable corrosion inhibitors. When special packing such as graph oils is used, the number of packing rings required will be more. To accommodate more packing rings, the length of gland is also modified. This design is called the deep gland. This is used for the high temperature services. But this cannot satisfy the regulatory codes. Means here fugitive emission standards of greater than 500 ppms. Hence, the frequency or use LDAR will result is excessive expenditure. So when we are using the gland flanges, packings and lanterns. Now next one is seat rings. In seat ring, the bottom there is a seat ring. There are two types of designs possible in seat rings. They are the integral and removables. In case of renewable seat rings, it may be either threaded, rolled in, or welded in. In case of integral seat rings, the seat material is deposited directly onto the wall body. The minimum hardness specified by the code for this material is 200 HB, that is 200 hardness and Brinell. HB stands for the hardness Brinell, 250 HB and 50 HB. Minimum differential between body and gate seats. The body seat being harder. Deposition of harder material like Selite 6 is also done for wall used in special services. The back seat arrangement is provided to repack the stuffing box when the gate is in full open position. The stem shall have an integral conical uh, or spherical backseat surface to sit against the bonnet backseat. And next part is yoke and yoke bush. Another part is yoke and yoke bush. Yoke may be integral with or separate from the bonnet. When the yoke is integral, the stem nut should be removable without removing bonnet. The yoke should have the same material of construction as that of sail. The yoke bush is normally NI resistance material. This is to prevent galvanic of the stem, as stem will normally be of nickel alloy. So next part is hand wheel and hand wheel nut. At the top there is a hand wheel and hand wheel nut. The hand wheel is affixed to the stem by a threaded hand wheel nut. The arrow pointing the direction to open the wall will be marked with word open or close. We can rotate these hand wheels and we can mark with the word open or close or shut unless the size makes it impracticable. Wall shall be closed by turning hand wheel in clockwise direction. The material of construction of hand wheel shall be malleable iron, cast steel, carbon steel, nodular iron, or ductile iron. Cast iron is not prepared, but nuts shall be of carbon steel or stainless steel. When the installed position of the wall in such a way that the hand wheel is not accessible, then the hand wheel are replaced by chain wheels and the wall is operated with chains. For large diameter walls where the operating torque is high, gear arrangement is provided to facilitate operations. Mostly bevel gear equipment is adopted. So we can recommend for specifying gear operators. Wall rating. So here class 150 and size 40-inch NB and above. Class 300 12-inch NB and above. NB stands for the nominal bore. And class 600 and above 8-inch NB and above. If remote operation of the wall is required, then this could be achieved through motor with limit switches. Proper selection of the drive unit should be done depending upon the services. Now next component is bolting. Normally high tensile stud bolts are used for bonnet bolts and low carbon bolts for gland and yoke boltings. Gland bolts are normally hinge bolts with hexagonal nuts. Next part is wall port. In wall port, the size is specified by the size of the end connections or the body end. The part of the bore is the passage through the wall. There are two types of ports design possible in gate walls: full bore and reduced bore. In class of full bore, the net area of the bore through the seat shall be as nearly practically equal to the nominal pipe size, that is APS. For reduced port wall, the port diameter is normally one size less than the size of the end. The compact design small bore, that is 1.5 inch gate walls are as per API 602 or BS 5352 unless the full bore design is specifically asked for. Manufacturers supply the reduced bore walls. The full bore design gate wall are also covered in BS 5358 and is designated as the standard bore. In full bore design, the net area of the bore through seat shall be equivalent to that of Schedule A T pipes. Here, Schedule T pipes, that is wall thickness for class 800 walls, and Schedule 160 pipe for class 1500 walls. In no case less than 90% of all the walls. In next lecture, we'll see the applications of gate walls. No, this is all about today's lecture. Do you have any questions, any doubts? Walls and their based on the functions, material construction, and connections. And first we discuss the isolation function type. So first one is a gate wall and their different parts. Yes. Yes, Sarang, Aditya, Tanmay, Siddesh.
No doubt, sir. No doubt.
No, sir, no doubt.
Atharva. Yes,
Yes, sir.
Atharva. Do you have any questions, any doubts?
No, sir.
Okay, fine. Then we'll close this session and we'll continue tomorrow.